So what happens when one of the people who invented the most successful AI architecture in history turns around and says we need to ditch it?
Yeah, that's not some crazy hypothetical. It's happening right now. And it points to this really deep, kind of uncomfortable secret at the very heart of modern AI.
Okay, so this all starts with a guy named Lion Jones. Now, if that name doesn't ring a bell, his work definitely will. He's one of the original authors of the legendary paper Attention is All You Need. You know, the one that gave us the Transformer, which is basically the engine inside almost every single AI used today. But here's the twist. He's now the one saying that the very industry he helped create has completely hit a wall. So why? Why would an inventor turn on their own world-changing creation?
So here's his core argument, and it's a big one. Jones thinks the entire AI world is trapped in what's called a local minimum. Now think of it like this. The Transformer architecture is so good, it's like we've climbed this really impressive hill, and now everyone is just, well, they're just walking around the top of this hill, making tiny little improvements, tweaking things here and there. But what they're missing is the giant mountain right next to them, the next massive breakthrough. They're optimizing for the small win and missing the giant leap.
Which, you gotta admit, leads to a pretty fascinating question. He helped build this brilliant trap, right? So why is he the one now sounding the alarm? Well, to really get it, we need to rewind the clock a little bit.
See, before Transformers, the big thing was a different kind of model called an RNN. And for years, researchers were just grinding away, squeezing out these teeny tiny gains. You'd see a paper get published that was all excited about an improvement from like 1.26 to 1.25 bits per character. I mean, it's progress, but barely. Then the Transformer just lands. Bam! It immediately hits 1.1, making years of that painstaking research totally irrelevant, basically overnight. Jones is worried that we're stuck in that same loop right now, just with Transformers.
So what is the real problem here? I mean, what's he actually trying to solve? It goes way deeper than just making faster progress. He's arguing that the fundamental issue with our current AIs is that they are absolute masters of faking it. They give us this incredible illusion of understanding, but deep down, something really important is just missing.
You see this all the time in what people call jagged intelligence. 1 second, an AI is solving a problem you'd need a PhD for, and the very next, it completely fails at a simple logic puzzle that a 5-year-old could solve. Jones's point is that this isn't just a quirk or something we can fix with more data. No, he says it's a sign of a deep, fundamental flaw in the architecture itself. We can brute force these models into giving us the right answers, but they don't actually get what we're asking.
Okay, here's a perfect way to think about it. The spiral problem. If you ask a standard AI to learn what a spiral is, you know what it does? It cheats. It just draws thousands and thousands of tiny, straight lines that look like a spiral. It's faking it. And because it doesn't actually understand the concept of a spiral, the math, the idea of it, it has no clue where the line should go next if you ask it to continue. A truly intelligent system would represent the spiral as an actual spiral. It would understand the rule and could follow its path literally forever. You know, it's the exact same reason AI image generators struggled for so long to just draw a hand with 5 fingers. We eventually fixed it, right? But how? We just drowned them in more data of hands. We didn't actually teach them the concept of a hand. We just forced them to memorize the correct pattern. It's a patch, not a real solution.
All right, so if the Transformer's the problem, what's the solution? Well, this is where it gets really interesting. Jones and his team at Sakana AI basically went back to the drawing board. They looked for inspiration from the one thinking machine we know actually works, the human brain. And what they came up with is something called the continuous thought machine.
And the absolute game changer here is the reintroduction of time into the equation. See, Transformers process a ton of information all in one giant parallel shot. But the CDM, it actually thinks step by step, sequentially. Its whole reasoning process is based on how its neurons fire together over time, which, hey, sounds a lot more like how our own brains seem to work.
So this new approach really boils down to 3 big changes. First, like I said, it thinks step by step. Second, each individual neuron is actually smarter. It has its own memory, it remembers its own history. And third, and this is the cool part, a thought isn't just a static snapshot. It's a pattern of synchronization, this dynamic dance of neurons firing in concert over a period of time.
Okay, that all sounds really cool in theory, right? But what actually happens when you build one of these things and start training it? Well, this is where it gets kind of wild. The CTM starts doing things, showing behaviors that nobody ever explicitly programmed into it. It starts to look, well, a lot like it's actually reasoning.
So, for instance, they trained it to solve mazes, and you can actually watch its internal thought process trace a path through the maze. And get this, if it goes down a dead end, you can literally see it pause, realize it made a mistake, and backtrack to find the right way. Your standard AI models, they just guess the whole path at once. They don't have this kind of trial and error process.
And this flexibility is it's amazing. Check this out. The researchers then gave the CTM less thinking time than it needed to trace the whole maze, just to see what would happen. And it didn't just give up or fail. No, it invented a totally new strategy all on its own. It came up with this leapfrogging algorithm where it would jump ahead, trace backwards to fill in the gap, then jump forward again. Nobody taught it that.
And maybe one of the most important things to emerge from this is something called calibration. Now, this gets a little technical, but trust me, it's a huge deal. Most AIs are famously, notoriously overconfident. They'll spit out a wrong answer and tell you they are 99% certain it's right. The CTM, though, it seems to have a genuine sense of its own uncertainty.
Just look at this chart. The CTM is almost perfectly calibrated from the get-go. If it tells you it's 90% sure about an answer, it turns out to be correct about 90% of the time. This just doesn't happen with other models without a ton of extra fine-tuning. It's like a smoking gun that something fundamentally different, and maybe better, is happening under the hood.
Okay, so to really push this idea of true reasoning, Jones's team created a brand new challenge. Think of it like a gauntlet, designed specifically to break any AI that can only mimic intelligence, and to reward the ones that can perform actual, strict logical deduction.
And how do today's biggest, baddest, state-of-the-art models do on this test? The huge transformers we hear about every day? They max out at around 15% accuracy. Let me say that again, 15%. It is a colossal failure, and it just perfectly highlights this massive gap between statistical pattern matching and genuine reasoning. And the reason it's so brutally hard is because these aren't your grandpa's Sudokus. They are these weird variants with bizarre, handcrafted rules written in plain English. Rules like any two digits separated by a knight's move in chess cannot be the same. I mean, wow. To solve that, a model can't just guess or see a pattern. It has to actually understand the rules and find that single, elegant, logical break-in point that cracks the whole puzzle, just like a human expert would.
So how on earth do you train an AI to do that? Well, it turns out you need a totally different kind of data. You don't just need the answers, you need the process. So the team turned to this amazing YouTube channel called Cracking the Cryptic, where these expert solvers spend hours verbalizing their exact step-by-step logical process. It's a data set not of facts, but of what they call thought traces, just pure, high-quality human reasoning in action.
And all of this brings us right back to that fundamental question. Are we on the right path to creating machines that can actually reason, that can build a constructive understanding of the world? Or are we just getting better and better at building these incredibly sophisticated parrots that are just masters of illusion? This new work on architectures like the CTM, it suggests a totally new path might be possible. But the final answer, that's still a very, very open question.